thank you to Sakura for inviting me to give a talk, and I picked the talk because this is something that has been talked about for a long time. People have talked about how barcoding would be so great and everything, and there's been a lot of presentations at NSH and other meetings about how to or why barcoding is such a great thing. But what I wanted to do is we went through the process of implementing barcoding in our laboratory, and I wanted to give the process of actually implementing it rather than just talking about how great it is. So that's what this presentation is about. I'm going to go through a few slides that reiterate the advantages of barcoding in the laboratory, but for the most part, we're going to talk about what the process is of actually doing that rather than all the benefits of it. One thing about this kind of process, any kind of software process, is every laboratory is going to be different. A small laboratory with half a dozen people is going to be a lot different than a large laboratory with 30 people. You know, resources will be different. The type of software you pick may be different. The path you take will be different. And there's really no set path. So I'm just showing you what you want to consider rather than giving you a definite roadmap. So one of the things that I wanted to show is that I put some handouts on here, and one of them, number 5 down here, is called Barcoding for Histology Outline. And what this is really is I don't know if you can see that on your screen, but what that is an outline of this presentation, and it's just written outline form. So it makes it a little bit easier to look at rather than looking at slides one at a time. It's written out. So the reason for implementing barcoding is to track specimens and workflow throughout the anatomic pathology laboratory, and we're talking about from accessioning all the way through delivery to pathologists for the most part. And really the big impetus to put in barcoding is to prevent misidentification errors that lead to incorrect treatment. And this has really been one of the big issues over the years, is how manual methods lead to pretty high error rates. And I'm just showing a slide now that shows what we calculated at UCSF using all our manual methods, which was entry blocks on a standalone printer, and then slides were handwritten, and then the labels were applied later. The labels were printed from our system, but they were applied later to the slides, and so these are the types of error rates that we were seeing. And then there are several studies out there, papers on the bottom box that show different institutions that implemented barcoding and what reduction in errors that they saw. So Henry Ford saw anything from 60 to 95% reduction in errors between cases. Western and Cleveland, they saw a 92% reduction in error rate on their slide misidentification. University of Washington on their block identification saw 99% reduction in error rate. So this is the sort of things we're looking at when you go to a system that is largely automated. The pass-offs between groups, say grossing to histology, is automated rather than manual. So the outside impression of histology is that they give us a specimen and we give them a result. And this is pretty much what they think of as this area where it says histology laboratory. To most people, including a lot of pathologists and residents, is pretty much a black box. They have no idea what goes on in there. All they know is that they get a result out. Our process is actually much more complex. This is a diagram. It's not meant to be read. It's just meant to show you the spaghetti of our actual process. And so this is the type of process that's actually going on when a specimen starts at the top and moves its way all the way through the system to a final report. Now, barcoding will affect the yellow boxes in this diagram. So it doesn't affect everything, but what we're trying to do is apply it to as much as possible. As soon as we get the specimen, we want to start the barcoding, and then when the final report comes out, we want to have that at the end of it. So this slide is just showing that most people that don't work in the health field, the only time they hear about a laboratory is when there's a mistake. And these are just clippings from different news articles that have come out over the years. And some of this was impetus for much more stringent processes like validation for immunochemistry, things like that. But a lot of this has to do with slide labeling or misidentification of specimens, which is what we want to prevent. So where the mix-ups happen, they can happen at almost any stage in the process. We get a requisition. They could be mixed up between samples. The samples could be mixed up or the blocks could be mixed up between samples. Slides can be mixed up between blocks all the way down the line. So every single part of the process has to be looked at. And then this slide, patient touches, gives you an idea of really how much you're touching patients all day long. So in our case, we kind of just did a simple average of our cases, and it comes out that every case is 17, we touch every case 17 times as it goes through our process. So that's 1,600 times per day that we're touching patients. So when you think about that, even if you have one mistake on a mislabeled slide, it affects a patient. So this slide, grossing efficiency, this is showing where barcoding eliminates steps. And a lot of the elimination has to do with automating processes or eliminating batch processes. For instance, in this case, on the left-hand side, we have group labeling cassettes at the beginning of the process, accession of the specimen, labeling, and then producing cassettes at the beginning when you get the specimen. So you may print out, say, 10 cassettes right then. And then you have to go through the process of moving those cassettes around and keeping them with this. This is a standard way that a lot of laboratories work because they may not have like say a cassette printer at their bench, a centralized cassette printer, so they have to print the cassette somewhere else, stick it with a specimen, then they have to move that whole thing around. And so that can lead to some problems. So what we're doing with barcoding is we're going through the process of actually printing ideally printing the cassette at the bench, at the grossing bench, rather than in a central location. And in that way, we eliminate that whole batch process of printing, and we print the cassette only as it's needed. It eliminates several steps in the process. If you do have to do central printing, then you do have a process of scanning the cassette along with the container in order to confirm that they match. If they don't match, then you can't go on. And then at the end, we have reconciling all these cassettes with a LIS, which often happens with a batch printed report, a paper report that you have to check off cassettes. While in the barcoding process, we scan the cassette to confirm that we got it. And then all we look for is things that are left over rather than checking every single one. Embedding kind of goes the same way. Instead of going through a long paper process, for instance, we used to print a batch log every morning, and then we would embed the specimens, then we'd have to go through and manually check off every single entry on that batch log against the block that we had. So that would take up to an hour a day to do that. Then we would have to go through the process of adding or removing blocks that we got didn't get, that were or not in the system. And then we would reprint the batch log once everything was corrected. And what we do now is we simply scan the block into the batch to begin with after grossing. Then we scan the block, and that takes it off the process log. And once embedding is done, we simply reconcile missing blocks, and which, in other words, blocks that are still on the log. And usually there's none of them, so it makes it a much easier process. Micronomy is similar in that we used to use a paper log that we would print out, and the way that they would kind of go pick up one page of that paper log, which would typically have about 20 blocks. They'd pick up those blocks from the tray that they were in, and then they would take them to the microtome, they'd cut, and as they cut, they would check off that they did the block. Then they'd handwrite the info on the slide, check off the slides, match them, and then they would sign off the work list when they were done. Now, with the barcoded blocks, we scan the block, the stainless appears on the screen, the labels print out automatically, they apply the labels to the slides, and then they put the slide in the and that's it. There's no paper involved at all. Okay, and then our problem two is that we have multiple grossing states. We recently opened a new hospital called Mission Bay, which is at the listed at the bottom here. So our process is very complicated. We have 3 sites where we do grossing, but we have 1 site where we do all the histology work. Mount Zion is where we do all the histology work, tissue processing, sectioning, staining, everything. But for instance, at the Parnassus campus, they'll gross large cases, transplants, things of that sort. They send all the cassettes to Mount Zion. They send all the biopsies to Mount Zion for grossing. And then at Mission Bay, they send, that's where they gross all the large cases. So, for instance, Mount Zion, they get large cases, but they send them all to Mission Bay to be grossed. And those cassettes go back to Mount Zion for histology processing. So we've got couriers going crisscrossing all day long. We've got 3 different couriers rotating around all these different sites all day long. And so it's a constant process to try to keep track of everything. So this type of case, computerized tracking is essential. And as I said, a lot of the tracking we did was on paper. These are examples of the logs we had, batch logs for morning, for the morning group, keeping track of things that handwritten logs of things that were missed or were missing or that we had to add on because they weren't put in the system. Just all kinds of process logs, keeping track of all the blocks that different types of blocks we cut during the day so we could keep it log our workload. We had a process board where people would write down how many blocks they cut of every type per hour, that sort of thing. So these are all manual processes. Every bit of this has now been automated and can be brought up in reports rather than writing down anything. This slide shows the ideal of what we're working towards. You have a container that has a barcode label, or we call it a barcode. It's actually a 2D code. A barcode, the nomenclature that everybody likes to use. It's a little bit easier. That you scan that container and you print out automatically a barcoded block or cassette. You fill that up. Those cassettes go off through tissue processing. When it gets the microtome, scanned and produce a barcode slide. So we have positive ID all the way through the system. That's kind of a recap of why barcoding is a nice thing to do. Good for patient safety, good for workload tracking, that sort of thing. So now we're going to kind of get into how you go about implementing this kind of system. And of course, the first thing you have to talk about is money. Do you have money to do it? Some places build their own systems. Maybe they have some talented people that sit down and just work it out. Small laboratories can often do this on their own. As you get larger and larger, more complicated, you need a commercial system that's going to cost you some money. Plus, all the hardware costs a lot of money. So at UCSF, we have to go through the capital expense route, and they give us a matrix to fill out. And the decision matrix, they call it, has these 4 items that we have to give answers to. And this, may be similar, a little different than what you have in your institution as far as how you justify something. Maybe you have to do a much more extensive justification, maybe quite different. But this decision matrix kind of comes out like this in this grid, and they score it. And I'm not sure how they came up with a score of 74. 100 is perfect. In other words, they buy it for you right away. Anything above 70 is good and goes on the list for a capital approval. So, our main emphasis was patient safety, and that and really the impetus for even thinking about this was that we had 2 very severe mislabeling errors that led to patients getting the wrong treatment. Luckily, nobody was harmed by that treatment, but it was a real wake-up call, and they, the institution of that is, what are you going to do about this? And this is what we said. Barcoding is going to help us prevent these errors. So that was a big justification. So we went and filled this out, and just talking about how we would identify every step along the way, positive identification, positive handoffs to every section, and being able to retrieve specimens when we need to, knowing where they are at all times, all that sort of thing. And the side benefit was that we expected it to improve turnaround time. Regulatory requirements, there's no regulation that says you have to use barcoding. Probably the closest is that you need to have 2 identifiers to have positive identification. But barcoding enforces a 2 identifier check because you're not doing human read, or you're not making typos by handwriting things. So it gives you a stronger link between two identifiers. Capacity for growth was the next section. And this has to do with, can we handle increased capacity if we spend this money? Our justification was that newer instruments, for instance, immunostators, can all handle barcoded slides. And their vendors have made it possible to hand off state orders to those instruments so that you don't have to do any manual programming. And presumably, by reducing time doing that sort of thing, you can spend more time staining slides and push more slides through. So we said we could handle more growth. And actually, it's turned out to be that way, as well as reduced turnaround time. And then operational efficiencies had to do more with making people more efficient, not having to do so much filling out of forms, spending time doing that. Reduce time sorting blocks, checking off blocks, that kind of thing, instead of have people do, what they're trained to do instead of doing clerical type work. And plus, we can capture a lot of data automatically rather than having people write it down or trusting people to write down the right numbers. So we can pull up reports and get all kinds of nice information now. So that's kind of the process we went through to justify the system, and we managed to get a high enough score to get put on our capital approval list. When I say capital approval, this is the kind of money we're talking about, and these numbers, I'll have to say, are simulated. I kind of rounded some up and some down. Some of them are real, some aren't, but just to give you an idea of what you're looking at for a commercial system. And probably the thing I really want to point out is that we initially looked at using a third-party tracking system, for instance, Ventana Vantage or Leica Cerebro, because the system we had at that time, which we still have, is Cerner Copath Plus. Their barcoding system that they were offering was very rudimentary, and Ventana and Leica were just light years ahead of them as far as capability. But as you can see, the cost is pretty similar, and there was a couple of things that came up that turned out that the Ventana Leica systems turned out not to be a good deal for us, because during the 2-year time period that we spent investigating the systems, Copath upgraded their system enough so that it was pretty much a match for either Ventana or Leica. And they told us that we would have to install their system anyway in order to communicate with Ventana or Leica. So it's basically, you have to install our system anyway. And if you want to buy this other system, that's fine, but we're going to charge you for our system as well. And so that kind of sealed the deal that we were going to go with a single, or our own vendor, Copath, and institute their advanced barcoding and tracking system. And it's worked out well, and I don't have anything at all. I mean, I think Ventana and Leica systems are really nice. We looked at some sites that they were using it, and we really liked it. And we especially like the reporting that comes out of them, which Copath doesn't have. And so, there's advantages, and the big takeaway you should take from this entire presentation is that you have to decide for yourselves what fits for your institution. And there's a lot of people that have installed Ventana, and some have installed Leica. It hasn't caught up to Ventana yet. But Ventana has 6 years or so, 7 years head start, and they've done a lot, over 100 installations at least. And they're very nice systems. So, I don't degradate them at all. They just didn't fit with what we needed. So, but just looking at this, obviously it's a huge cost. Hardware alone is $100,000. Just barcode scanners, those handheld scanners that you use, we spent over $30,000 just on those because we have over 100 seats that use them. We have our histology lab's the smallest part of it. We have maybe 20 scanners in there, but we have 60 pathologists, 25 residents. We have a dozen or so administrative people, supervisors, all kinds of things, So we ended up getting well over 100, about 120 barcode scanners just to be able to use the system. So when you look at numbers like that, the numbers go very fast. But you're looking at, the cost for the software, the cost for implementation of the software, which is basically the implementation process. You're paying them to help you do it. And professional services, which is things like custom coding that you may need. We ended up spending about $8,000 in custom coding beyond the original software. And then it comes to seat licenses. Do they charge you a license per seat? Anywhere from, $50 to $100 a month to $1,000 a month or something, sometimes. So those are things that you really have to look at, and those are the things you have to kind of flesh out a little bit, at least before you even start asking for the money. We spent about a year just looking at different systems and getting some gross quotes from them. They weren't detailed quotes. They were just kind of, this is the ballpark type quotes. And before we even started asking for the money, so we had an idea of what we were looking at. And then we padded our request, of course, in order to cover contingencies. So, and then the third part you have to think about is your internal. If you're a large institution like UCSF, we have our own IT department. We can have them do work for us, but they recharge us for it. So, there's some things that they charge for, either planning or things like determining, testing items, implementing things, all kinds. They charge for all kinds of things. So that's another thing you have to think about. So that's the money side of it, and it's good to try to get in a reasonable ballpark before you ask for the money, so you're not surprised later on. So this is kind of just a outlined implementation path. The first part is preparation. Second is implementation, and third is post-implementation. And the preparation part is the longest. We were talking about years sometimes. We spent probably 2 years preparing for this, looking at systems and things, and then implementation is probably anywhere from 4 to 6 months. And then post-implementation might be 2 to 3 months cleaning up issues afterwards. So we're going to go through each of these types of things. I'll give you a little bit more detail. So during preparation, we're looking at identifying the resources that we have available, workflow modifications that we may need to do, identifying software vendors that would fit for our system, any kind of hardware that we think about that we need, and IT infrastructure. And then the implementation part is you're identifying a team to do the implementation. You set a go-live date, and this is something that we set a go-live date that we tied into our performance goals. So that was something that we really wanted to make so we get our money, and then our bonus money, and then any changes to be made in your current system, hardware, implementation and installation, IT infrastructure, training, testing, go live. We'll go through all this more. And then the post-go live is identifying any issues that come up that didn't show up in testing previous, and then resolutions to those, and then a final acceptance. I went through the little bit of capital request, the money side of it, and touched on the idea of would you use your own vendor, your current vendor, LIS vendor, or would you use a third party? So these are this slide is some of the things to think about when you're doing the capital request. And on the software side, current, you could upgrade, you may do enhancements to yours to implement it. Your current LIS plus third party, or a third party, and all you do is the barcoding and tracking within the laboratory. Some places are doing that. They just pass off to the lab, and the lab tracks it only within the laboratory. Another idea is that maybe you look at it and the price is high enough, or maybe you have an old system, or maybe you don't have a system, so maybe a new system is the way you want to go with it. Totally new. Some of the newer systems out there are designed for barcoding right from the start, and they have much more modern software. And then you have to think about the institutional recharge. I mentioned our IT department. We also have a project management department, and they basically take over management and manage it for you. In other words, they set up all the meetings, they handle all the timelines and everything, and that can be helpful because that's what they do for a living, so they know how to push things. Hardware, one of the things you have to think about is if you're doing your own system, in other words, you're upgrading your own LIS, or you're doing a third party that doesn't sell any software or hardware, then you have to do all your own hardware. So then you have to do all the testing, all the picking of hardware, all that sort of thing. So, and while a turnkey system like Ventana or Leica, they supply all the hardware, they spec it, and they supply it all. It's just included in the cost, so you do a lot less work on that side. And then you have to think about instrument interfaces. Right now, it's mainly immunochemistry instruments, but special stain instruments can also interface. There's a couple of H&E standards out there that will read barcodes and use those to stain. So those things to think about. You have to talk to the vendor about the interface, whether it'll work with the system you're thinking about, and then the hardware that's involved in it. So you have to prepare by identifying the resources, and the first, of course, is your current LIS capabilities. Do they have the capability to even implement barcoding, or are you forced to go to another third party or do something else? The bottom line there, in-house resource is mainly, do you have the capability in-house to produce your own system? Some places have done this and they've done very well at it, but it can take years to. So for your current LIS, if they offer a barcoding system, is it already there, or do you have to install it new? You have to install another module, or how big is the upgrade? For instance, some of the barcoding systems out there that can be upgraded to your current LIS are for the current version only. So maybe if you're 1 or 2 or 3 versions behind the current version, you may have to do an extensive upgrade to the basic LIS before you can even talk about barcoding. Just some of the possibilities of your current LIS, or using your current LIS with a third party or third party alone. The issues to think about with third party vendors. Like I said, there's some very good ones out there. I mentioned a couple, but there's 5 or 6 out there that can do it for you. And the thing to think about is, have they ever integrated with your LIS? We talked to several vendors who were very anxious to provide a barcoding system for us, but they had never integrated with CoPath. And CoPath is kind of a little bit leery about integrating with just anybody. They have to be validated, and they have to CoPath will do an approval route for any vendor that wants to integrate with their LIS. They're happy to do it, but it's something that can take a lot of time. So if it's something that you're working on right now, it may not be ready for a while. If they have integrated with your LIS, how many installations have they done? Is it 1 or 2, or is it 50 or 100? Obviously, the more they've done, the more experienced they are with it, the more they know about it. Where does their system fit into your LIS workflow? This has to do with, where does the barcoding start? For instance, we found we had to install CoPath anyway, CoPath ABT anyway, to work with a third-party vendor. And then CoPath also said they would not do bidirectional information sharing. So that what that meant is that CoPath would pass information to the third party. They would not accept information back from the third party, except for getting the status update. For instance, if a block went from labeled to gross, they would take that status update. But if you were to ask a Ventana Vantage and enter 10 blocks into Ventana Vantage, Ventana cannot send those 10 blocks and have it written back into the CoPath database. So what that means is that you're kind of stuck with using CoPath to enter all the blocks, and then it has to be passed off to Vantage to do any tracking on it. So that's what I mean about, where does it fit into your workflow. So in that case, we would have to enter everything in CoPath at the grossing bench, and then if we had Vantage, it would pick it up after that, and we would start tracking after the cases were gross. Then we could track through histology, and that would be no problem. But nothing that was done in Vantage would be written back into CoPath. We would lose all the tracking information. Or it would be in Vantage, we could get it out of that, but it would not be in CoPath. And the same thing goes with any kind of states entered, extra blocks entered, any kind of process entered into CoPath. It would have to be sent to Vantage, and then Vantage would just hold it. But then you have to ask yourself, do you want to have those 2 systems? And then how does it integrate with the IHC special stater? Where do you integrate? Again, it has to be sometime when you do an order for a state. And so which system do you put the order in? And how do you track it? And does layering the third-party system on top make financial logistical sense? What I mean by this is obviously financially it may cost you more. Logistically, you got to now take care of 2 systems, and you may have 2 different databases that you're drawing information from. So then when you want to do information analysis, you may have to draw from 2 systems and combine the information. Again, institutional recharge, different things you may have to think about. This maybe only large institutions, smaller places may just absorb the cost, or maybe they'll farm it out to a third party. So these are just some things to think about. But some in-house resources, IT expertise, they have expertise in everything from project management, program. They may have programming. Our IT department doesn't do programming. Some institutions do have that capability, but ours does work, a lot of install a lot of networks. Laboratory experience. Does your staff have experience in barcoding somewhere else, or done something like that somewhere else, or it's a different type of job, but do they have experience in this kind of system or projects? Just simply managing projects, working on projects. There's a lot of testing and things involved. So if you have people that have that capability, have that experience, that's very helpful. And then you need your champions, of course. You need your lab administration, institutional administration. Everybody has to be on board with this happening. Especially your medical directors have to be there, because a lot of the end users are going to be pathologists that have to scan slides to show they got the slides, or order stains in the system in a certain way. Everything has to be done in the system. It can't be all just word of mouth anymore. And then you have to put your team together and make sure they understand they're working on this for many months, sometimes years. Hardware, again, specified and supplied by the barcoding tracking vendor, and then you buy it yourself, or do they supply the hardware? If they supply it, it'll be wrapped up in their total cost. Sometimes they'll do some kind of consumable offset where you're buying labels from them that offset some of the cost of the hardware. And if you're doing it yourself, in other words, you have to decide on all the equipment, all the label printers, cassette printers, barcode scanners, all the setup, extra computers you may need, that sort of thing. Then you should assume you're going to have to demo all this, get demo units, test it, be sure it all works with the system. So you may have to demo several models or vendors, and capital expense may require long lead times to get the financing in. And installation could take time. For instance, we installed 11 touchscreens arms, and it took them a long time to get done. I'll show you some pictures of that later. So that actually delayed our project by a couple of months, having the installation of all those done, because they had a custom fit on them. And then network infrastructure, any kind of network infrastructure is going to require IT approval, planning, and installation, and you have to decide if you're doing hard network drops. In other words, that you're plugging a wire into, then you're going to have to plan those very well. We thought we planned for everything. We ended up adding half a dozen more when we were finished, just in the laboratory. If you can go wireless, that's great. Some places will not, like for our system, they said Copath takes up so much bandwidth that they wouldn't do wireless on it. We had to go hard wiring the whole way. Then your AC interfaces. This is probably one of the greatest, besides tracking specimens and reducing errors, this is probably one of the greatest benefits of the barcoding, because what we do now is a stain order comes in, when they scan a block to cut it, any immunostains at that time are sent right to the stainer, and then the label that's put on the slide is read by the stainer, and we're using Leica bond stainers for this, and so that completely eliminates all the programming that has to go into the stainer, and our turnaround time literally dropped by hours when we started doing this, and much more accurate as well. So in this case, a stainer interface has to go from the LIS to the stainer. So you're going to have, at least in our case, we have a couple of parts to that. The first is we have an order. It goes into a stain, what we call a stain manager, and you have to have one stain manager for each type of instrument. So we have like an antenna. So we have a stain manager for each of those, and each of those stain managers cost some money. And then the vendor interface is on the other side that picks up that information that's coming from Copath. So there's one of each of those, and those cost money as well. And so now we've got stains going two different ways. The system, stain dictionaries, everything, order dictionary, everything has to be set up to make sure that those things feed the right stainer. Every stain is set up to run on one stainer, one type of stainer. So this requires a lot of coordination between Copath, the vendors, and our own IT group. And one of the issues with this was that they didn't want these standard computers to have access to the rest of the network. So we had to put in firewalls between the stainers, and the rest of the network. And this is something that kind of surprised me, but not totally. But I was reading some newspaper articles after that and found out that hackers now are getting into IT systems through things like copy machines, laser printers, all kinds of different instruments that have computers in them now that are on networks. And so a stainer like this is on the network, and it's possible that somebody could hack into that stainer. So it's kind of interesting how all this is going. So another thing to talk about in the preparation is workflow modifications. There's a saying, and we heard this from every single group that we talked to about barcoding in the years that we're planning for this, is that barcoding does not solve poor workflow. It simply barcodes it. So that's something to take to heart, and take, if you're going to implement barcoding, is to take the opportunity to look at your entire workflow system and see where you're having wastage and perform lean studies and solve problems before the implementation. So these are the 5 major areas that are affected. You've got accessioning, grossing, tissue processing and embedding, micrometry, staining, and slide distribution. So you should go through each of these areas, map out their workflows, and identify any kind of wastage that's going on there. And by wastage, we're mainly talking about things that are waiting around to be done and things that have to be sorted, or things that have to be redone, restained or recut, whatever. So this is one of our early attempts at mapping a workflow on a board. We would sit in a room, just talk out the whole path, and then once this was finished, we would put it into a Visio diagram, and so it was easier to look at. But I wanted to go through one example of a workflow modification. This has to do with grossing, handling cassettes. So several years ago, the process for grossing was to print a cassette on a standalone printer. This is one of those like Raymond Lamb printers. So they would enter it in CoPath, but then they would turn around to the printer and enter it again. And then they would produce the printed cassettes out of that printer. But then when they put the tissue in the cassette, they would just throw the cassette in a bucket. And we're talking about a big, gallon bucket or 2-gallon bucket, 4 of them that were sitting at the bench there. So the cassettes in that bucket were totally random. And then it came to histology, and we would sort them out, and we would determine if there was any missing or add-on cassette. By missing, I mean that they entered it in CoPath, but we didn't get it. And add-on was that we got cassettes, but they never entered in CoPath. And because of the fact that they could print cassettes on the standalone printer, they could do whatever they wanted and ignore CoPath. So this was very common, or if they were rushed at the end of the day or something like that, they would get all these what we call mistakes, and they would call efficiency. Anyway, we talked about 150 blocks per month that were either missing or add-on that histology had to solve. They had to do all the resolution of it because we were ones getting the blocks. The grossing took no responsibility for doing that at all. So basically, that resolution and sorting was completely wasted time. And on top of that, because they were random, we had to spend a lot of time sorting slides, or sorting blocks every morning, hour and a half every morning, just sorting blocks. So our first thing was to start having them put the cassettes in racks by case. And so then we did less sorting in histology, but we still had missing the add-on issue. We started using a printer that was connected to the LIS. And so we had to buy printers, cassette printers that we could connect. And so we did that. We entered the block in there, and the missing add-on blocks were reduced by 95%. We still did some sorting because they didn't get all the blocks in the right order for the most part. Pre-barcoding, grossing would match the case to the cassette manually. There was no control on adding or deleting blocks, and histology determines the add-ons and missing, though less than previously. With barcoding, grossing was forced by the system to match the cassette to the case by scanning. They had to scan the cassette and the container to show that they matched. Any cassette that was not used was automatically canceled by the system when they would close out the case. And now histology has 0 missing or add-on blocks. So this is something, it wasn't totally barcoding that did this, but having the cassette printer linked up and forcing them to put the cassette in racks that helped out histology. So there's a lot of components to this, but this definitely helped out when barcoding came in, it helped out a lot because we didn't have to sort things out by that time. In other words, this process took about 3 years to get through all this, but by the time barcoding started, we had grossing in good shape, and so we didn't have to deal with that on top of barcoding. So now with accessioning, we get a requisition, it has a barcode on it here. We scan that, all the information goes into our system. We produce labels. These are kind of dummy labels for testing, but we use the small 22 millimeter by 22 millimeter stainless steel labels for all our containers so that we can put on everything from biopsy to big containers. And so we print out container labels and requisition labels. Where they start the case, they have to scan the requisition and the container in order to start the case. They print the sets pretty much one at a time, or maybe a small batch. They can order, a number of cassettes as they need, but they're really encouraged to only use, print a little less than you think you need, and then print, the last bit as you need it, so that you don't overprint cassettes. And then when they grow in tissue, they have to scan the cassette at the finish to show that it's part of that case. So this is kind of what they go through in grossing. They have to scan the requisition and containers to start. If they scan the wrong ones, then they get a warning saying that it doesn't match. It goes on to showing when they scan the cassette at grossing, it shows that it's turned to gross here, so they know it's finished. And then in histology, it goes into tissue processing. We scan the processor, the cassette to produce a batch, so we positively know that that cassette is in that batch because we scanned it. At embedding, they scan the block, and at that time, its status gets set to embedded, and their case information shows up on the screen, and it also gets the timestamp and the person who embedded it, which makes it very easy to go back and figure out embedding problems. And then microtomy, they scan the block, they get slides and stains ordered. Anything that was ordered shows up on the screen, labels are printed, unstained gets labels as well. And then at the same time as that happens, IHC orders are sent over to the IHC stainer. Tissue processor, this is showing you scan the block in and you get this, just shows the block that's put in the tissue processor. Embedding, this is what you see in embedding. Shows you what it is. If they put in the number of pieces, it'll show up. If there's any comments on the block, it'll show up here. So they see this for every single block. And then at cutting and sectioning, when they scan the block, they get the list of slides to cut. And then at case assembly, after staining, they scan the blocks and it gives you a blue check mark for every slide that you scan. And then if a non-case slide is scanned, it gives you a red pop-up. One thing that I'd like you to understand out of this is that the cassette is the key to the entire system. On the left, it shows scan cassette, and it shows where cassettes are scanned: grossing, tissue processing, embedding, microtomy, and recuts. When you look at the other items, a requisition is scanned only at grossing, containers only scanned at grossing and storage, the slides only scanned at distribution and by the pathologist, and then at storage. And so you can see that the cassette is what is scanned the most. And what I'd like to emphasize is that you should look at getting the very best cassette printer you can and make sure that your cassettes are printing extremely well and that the print survives everything you're going to throw at it, because these things are going to go through all the tissue processing, they're going to go through decal, they're going to be scraped and embedding, they're going to be knocked around. So they really have to survive everything. We did a lot of testing in cassettes. I mean, we put them through all the process, start to finish, hundreds of them to be sure that, and then we would scan at every step to be sure that they were working. And we really have had very few problems with cassettes. The issues that come up sometimes is if the printer prints off a little bit, and we've gotten growing staff to be looking at cassettes, that if they see any issue with the cassette, like if it's for some reason printed high or printed to the side or something, that they have to reprint that cassette so we don't have a problem. Because once it leaves grossing, it has to go through all these other steps. If there's a problem at any step, it's going to stop. And you're going to have to do manual entry, or at some points we'll do re-embedding. For instance, at embedding, if they can't get the cassette to scan, we'll print a new cassette right then before they embed it. That way we'll have a good cassette throughout the rest of the process. It's really important to do that because you've got to use it all the way through. Identifying software vendors, we kind of went through this, but this is where you're going to have to get vendors to come in and show you what they have. Ideally, you'll do site visits. Preferably, you'll go to a place that has your LIS or the LIS you're using, and they're using the vendor software as well. Similar size as your institution, similar problems as you may. Do as many site visits as you can. We did 4, I believe, 1 for each system, and then key members of your team need to go. Your IT people, your administrator, the people who are on your implementation team need to go, your histology supervisor, key people that are going to work on this system to see what it looks like. Different people see different things when they look at a system. It's really good to get their viewpoint and see what sort of problems they see. But the site visits are really a huge part of this evaluation. When you finally choose a vendor, you're going to write up a contract. And basically, the contract is saying who does what. So you need to be sure it's identified and that you understand exactly what the vendor's going to do, what kind of system changes they're going to make, whether you'll need custom programming or, you allow some leeway for custom programming because it probably will come up. And then really, how do you know when they're done? How do you know when the system is finished? Is it the day you go live or is it 2 weeks later? Those are the things you have to figure out in the contract. What hardware is supplied, what they're going to do, if they can specify hardware, if they're not supplying it. In other words, they may have tested certain hardware that they know works and that they would like you to use. And then you have to identify an in-house team, both the vendor, your in-house people, any other vendors like for equipment that are going to test workflow, test the equipment, and train people. So this is an example of a simple contract. I took out all the prices on it. I don't think they want me, and the prices we paid, but it just kind of gives you an idea of the different types of things that are on the contract and what it's lined out for. And then choosing hardware, again, this is vendor versus institution supplied. And it may be you look at the vendor system, you don't like it, so you want to switch it out. But definitely look at what other people are using, ask a lot of questions. One of the things we did is we made grid comparison tables. So we would put on the left-hand side all the features that we wanted, and then on the top the different vendors, and then we'd put down in every cell how their system applied to that need. And it was very helpful to figure out exactly what everybody's had, and very easy to look at. And really, you need to have a comparison. So don't get too complicated, but think about what you want to have, what you think is essential, what would be nice to have, and what's not that important, and try to keep it at that. If you try to get in 5 or 6 variables, you're going to go crazy. So keep it down to really, really what you really want. And then what we have to understand is with the software, with the hardware, with everything, there's no perfect system, and there are trade-offs. And so you're trading off either convenience for price or something like that, and you have to decide what trade-off you're willing to live with as you go along. So typical hardware, you've got step printers, requisition, container labels, barcode scanners, all this sort of thing. We end up with many keyboards, many mice, mounting hardware, network drops, or whether you can go wireless, testing everything for function as you go along. Implementation, you've already got your implementation team. You've got to put in all your hardware, get all your training done. We did a staged go live, so we didn't do everything at once. We did some of the smaller things earlier, some of the smaller things later. Did histology on the main go live day. This is our setup. We have a touch screen, standalone. This is an all-in-one computer, barcode scanner, printer, label printer here. These are some of the mounts that we used. This mount, if you can see, there's a rail on the wall. So these computers are on mounts, so they can be slid to either side of the microtome. Makes it very nice for setup. They're not hard on one spot. I included some training documents in the handouts as well. So at the end of this, when you finally go live, nothing is perfect, so you're going to have some problems. The big thing is to start issues log and perform the analysis. This is our issues log that we had set up. People just go up and write up any issue that they had with the system, and then we would, as soon as possible, try to resolve it. Our general label, just a few pictures here. This is our consult labels, slightly different color, designed to stick to person. Then our pathology label, this is our old label, this is our new label for the Cytex machine. You still have problems with grossing. If they put much ink and it leaks out, it can affect the barcode. These wouldn't read. We had to reprint these cassettes.
We do have a couple of questions that people are welcome to send along to here. And as questions keep coming in, I just want to let everybody know that this month's featured products are the SmartWrite cassette printers. We have on-demand cassette and slide printers, and they print in ink. You can do 1D and 2D barcoding. You can reach out to your Sakura or Cardinal rep for additional information. I'm going to go ahead and start with the questions. One of the questions is, and it's a long one, so it says they are in the early stages of adding barcoding to their process. The problem they have experienced is the vendor of our cassette etchers claims that a 2D barcode only holds enough space to print 20 characters on the block. This isn't enough for us to print an accession, block identifier, and patient name. What cassette etchers are you using, and how many characters can you print on your cassette?
If they're using a barcode, in other words, a linear barcode, the one you see with the up and down lines, that could be true. If you're using a 2D code, then it can hold plenty of information. And that's why you'll see most of these systems are going to 2D. They call it 2D data matrix or other. Yeah, here's on the screen there. You can see the 2D code. And so that might be, I'm not sure what etcher it is. We use the Leica IPC, the inkjet printer, and it prints fine. We also tried out the thermo printer, PrintMate, and that worked fine. We were actually waiting for the SmartWrite to come out, but it didn't come out in time when we did our system. We were pushing our rep to get it to us, so we did it out. But the printing from that looks beautiful. Data General looks beautiful. They're laser printers. So I'm not sure exactly. If it's a barcode, it could very well be the case, but 2D should hold all the information you need.
With that, thank you and have a great day, everybody.